Typhoon Watch just went up for 200,000 American citizens, and the storm behind it is doing the single most dangerous thing a storm can do. It is rapidly intensifying. One day ago, Bavi was a strengthening tropical storm far east of Guam, with no watches posted anywhere. Tonight it is forecast toward Category 5 strength, winds near 170 miles per hour, seas to 45 feet, bearing down on Guam and the Northern Mariana Islands, and we cannot fly into it to measure it. Everything we think we know about its strength comes from reading satellite pictures from a distance, so the number on the screen could be right, or the monster out there could be even worse than the screen is telling us. How will we know before it is too late? One thing before we get into it: if you enjoy what we do here at Project Nightwatch, hit like and subscribe so you don't miss any of our nightly debriefs, and tell me in the comments where you're watching from tonight. Let's get into it. Part 1. The warning that appeared overnight. 200,000 Americans woke up this morning inside the projected path of a storm that did not exist as a threat to them 1 week ago. They are not on the mainland. They are not in Florida or Texas or along the Gulf Coast where the country instinctively looks when the word typhoon or hurricane enters the news. They live on a handful of islands in the far western Pacific, closer to Tokyo than to Los Angeles, and this morning the National Weather Service office that serves them did something it had not done a single time during this entire storm's life. It issued a Typhoon Watch. The headline on that bulletin was not written in the careful, hedged language forecasters usually reach for. It read, in plain capital letters, Typhoon Bavi intensifying rapidly east of Guam. That single word, rapidly, is the reason you are here tonight. Because a storm strengthening is normal. A storm strengthening rapidly, in the span of a single day, on a direct line toward American soil, while the tools we use to measure it strain at the very edge of what they can see, is something else entirely. What is happening east of Guam right now is one of the most dangerous things the ocean is capable of producing, and it is happening on a holiday weekend, aimed at people who are, in every legal and human sense, our fellow citizens. And it is doing it faster than almost anyone expected. Let me tell you exactly what we know, because the numbers themselves are the story. As of this morning, July 3rd, 2026, Typhoon Bavi, designated as Storm 09W by the Joint Typhoon Warning Center, is churning through the Philippine Sea to the east of Guam and tracking generally toward the Mariana Islands. The forecast at the National Weather Service in Tinian, Guam has put on the table for the waters around those islands describes winds near 150 knots, with gusts reaching 180 knots, and seas building to as high as 45 feet. Let me translate those numbers out of the language of meteorologists and into something you can feel. 150 knots is roughly 172 miles per hour. Gusts of 180 knots are pushing past 200 miles per hour. And on the scale most Americans actually recognize, the Saffir-Simpson scale we use for Atlantic hurricanes, sustained winds near 170 miles per hour is a Category 5. The strongest category there is. That is the storm that a Typhoon Watch was just issued for. And I want you to sit with the specific meaning of that watch, because a watch is not a warning, and the difference matters. A watch means those conditions are possible within roughly the next 48 hours. It is the moment the forecasters stop saying this might become your problem and start saying you need to be ready now. For the residents of Guam, of Rota, of Tinian and of Saipan, that moment arrived overnight. And to their north, on the smaller, more remote islands of Alamagan, Pagan and Agrihan, a separate tropical storm watch has now gone up as well, because the reach of this system is widening even as its core tightens and strengthens. Here is what makes this genuinely unsettling rather than simply serious. Bavi is forecast to reach typhoon conditions, meaning sustained winds of 64 knots, or greater, within the next 48 to 72 hours. That is the window. That is how much time roughly 200,000 people have to finish preparing for a storm that could arrive at Category 5 strength. And the reason I keep circling back to that number, 200,000, is that it is not an abstraction. It is the combined population of Guam and the Commonwealth of the Northern Mariana Islands. These are United States territories. The people who live there are American citizens and American nationals. They carry United States passports. Their children are born on American soil. And tonight they are staring down the barrel of a storm that the rest of the country has barely heard of, because it is on the far side of the international dateline, and it is not pointed at a coastline with a famous name. If you were with us yesterday, you already know that we were watching this. Just one day ago, we told you that the strongest storm on Earth was taking shape in the Pacific. At that point, Bavi was still a strengthening system more than 950 miles east of Guam, moving west-northwest, with winds that had climbed from around 45 miles per hour to around 60 miles per hour in a single morning. It was a forecast. It was a warning about what was coming. There were no watches posted. There were no warnings on any island. It was a storm with potential. In the roughly 24 hours since, that potential has started to become real. The watches are up. The projected peak has climbed toward Category 5. The window has narrowed from days to hours. This is no longer a story about what might happen. This is the story of a storm doing exactly what we feared it would do, and doing it on schedule, and the schedule is fast. That change, that acceleration from possibility to reality in the span of a single day, is the thread that runs through everything I am about to tell you tonight. Because the central mystery of Bavi is not whether it is dangerous. We already know it is. The mystery is how strong it will actually be when it reaches those 200,000 people, and whether the instruments we have can tell them the truth in time to matter. I do not use the words Category 5 lightly, and I want to be precise about what that label actually represents, rather than let it wash over you as just one more piece of frightening vocabulary. On the scale we use to rank these storms, the categories are not evenly spaced steps up a gentle ladder. Each step represents a dramatic jump in destructive potential, and the top category is reserved for storms capable of catastrophic damage, the kind that can render an area unlivable for weeks or months. When forecasters reach for that top label, they are not reaching for drama. They are telling you that the ordinary rules of what a building can withstand and what a community can absorb no longer apply. That is the tier Bavi is forecast to reach as it approaches the Marianas. Here is what makes the specific figure the National Weather Service put out so alarming. Winds near 150 knots is not a round, comfortable number chosen for effect. It is a precise projection, and it sits right at the threshold where a super typhoon becomes something close to the strongest version of itself. In the Western Pacific, forecasters use the term super typhoon for storms with sustained winds of at least 150 miles per hour. Bavi is not merely forecast to become a super typhoon. It is forecast to climb well past that threshold, toward winds around 170 miles per hour. This is a storm reaching for the upper end of what the ocean can build. Now consider the calendar, because the calendar sharpens the whole thing. It is early July. We are near the beginning of the Western Pacific's most active season, not at its climactic peak, and yet the ocean is already producing a storm of this ferocity. When forecasters raise the possibility that Bavi could be a candidate for the strongest July typhoon to directly threaten the Marianas in the reliable record, they are pointing at exactly this, the mismatch between how early it is in the season and how extreme this storm already is. The machine that builds these storms is running hot, and it is running hot early, and the first 200,000 people directly in the line of what it has built are American citizens. I keep returning to that citizenship not to make a political point, but to make a human one, because it changes how the rest of the country should feel about this. When we talk about Bavi, we are not talking about a distant foreign disaster that we watch from a comfortable remove. We are talking about our own, about communities that fly the same flag, whose losses this weekend will be the nation's losses. The escalation from a distant forecast yesterday to active watches today is not happening to strangers. It is happening to fellow citizens, and it is happening fast, and the exact strength of the thing that is coming for them is still, tonight, an estimate we are reading off a screen. There is a temptation, when a storm is still out over open water and the sky over your own home is clear, to treat all of this as something happening elsewhere, to someone else. I want to gently push against that temptation, because it is exactly the gap in attention that has left these islands undercovered in past disasters. A storm does not become real only when it makes landfall. It is real right now, tonight, spinning up over the warm water and the decisions being made in the next day, by families, by emergency managers, by the people who will either be ready or not, are being made under the pressure of a countdown that is already running. The distance between us and the Marianas is a distance of miles and ocean. It should not also be a distance of attention. Stay with me, because to understand why this particular storm is keeping forecasters awake tonight, you first have to understand exactly who is standing in its way and why the ground they are standing on makes everything worse. Part 2. The 200,000. Guam is a small island, but it is not a small place. It stretches only about 30 miles from end to end, a piece of land in the Western Pacific that most Americans could not find on a map, and yet it is one of the most strategically important pieces of territory the United States possesses. Around 150,000 people live there. They are American citizens. Just to the north lies the Commonwealth of the Northern Mariana Islands, a chain that includes the inhabited islands of Saipan, Tinian, and Rota, home to roughly another 47,000 people who are American citizens and nationals in their own right. Add those numbers together, and you arrive at the figure I keep returning to. Roughly 200,000 Americans live directly in the region that Typhoon Bavi is now forecast to threaten, and every one of them is inside the cone that appeared overnight. I want you to understand the geography, because the geography is not neutral here. It actively makes the danger worse. These are not large land masses that can absorb a storm and dissipate its energy across hundreds of miles of interior terrain. These are islands, small ones. When a storm the size and strength of Bavi approaches an island like Saipan or Tinian, there is no inland to retreat to. There is no drive 300 miles north and get out of the way. The entire population lives within a few miles of a coastline, and every one of those coastlines is exposed to the open ocean. When we talk about seas building to 45 feet, we're talking about walls of water taller than a 4-story building, bearing down on communities that have nowhere higher and no farther inland to go. And this is where the specific list of islands under watch tonight starts to tell a story of its own. The Typhoon Watch covers Guam, Rota, Tinian, and Saipan, the 4 most populated islands in the region. But the Tropical Storm Watch that was added covers Alamagan, Pagan, and Agrahan, 3 of the northern islands, which are far smaller and far more isolated. The fact that the watches now stretch that far north tells you something important about how the forecasters see this storm. They are not drawing a tight little circle around one island and hoping for the best. They have widened the alert to cover a large stretch of the Mariana chain, because the exact track is still uncertain, and because a storm this powerful throws its dangerous winds and its storm surge and its punishing rain far beyond the position of its centre. Think about what these communities are actually facing in practical terms. The forecast calls for storm total rainfall on the order of 10 to 18 inches. On a small island with steep terrain and limited drainage, 10 to 18 inches of rain is not an inconvenience. It is flash flooding, it is landslides, it is roads cut off, and neighbourhoods isolated. Layer on top of that the wind. Sustained winds near 170 miles per hour do not damage buildings. They erase the weak ones and test even the strong ones to their structural limits. Power lines come down, water systems fail, communication towers snap, and because these islands are so remote, so far from any mainland source of help, the aftermath of a storm like this is measured not in hours, but in weeks and months of recovery, with supplies and personnel having to be flown or shipped across thousands of miles of open ocean. This is the part that the rest of the country tends to miss, and it is the reason I want to slow down and make it clear. When a Category 5 hurricane threatens Miami or New Orleans, the entire national machinery of attention turns toward it. There are live broadcasts, there are evacuation orders covering millions, there are days of wall-to-wall coverage. But when a storm of the exact same ferocity threatens Guam and the Northern Marianas, it often unfolds in near silence on the mainland, precisely because these 200,000 Americans live so far away, across an ocean and across the dateline, in a place the national conversation forgets to look. The storm does not care about that gap in attention. Bavi is just as dangerous to a family in Saipan as it would be to a family in Tampa. The only difference is who is watching, and there is one more layer to the human stakes here, one that turns this from a serious storm into something closer to a cruel one, and I will come back to it in detail later. These specific islands, Saipan and Tinian in particular, are not starting from a position of strength. They were struck earlier this year by another powerful storm, and parts of them are still rebuilding. So when Bavi bears down on them now, it is not hitting a fresh, fully repaired community. It is hitting people who are already exhausted, already stretched, already living with the damage from the last time the ocean came for them. Hold that thought, because it changes the meaning of everything the forecast numbers describe. There is one more dimension to Guam in particular that most Americans never consider, and it adds a layer to why this storm matters far beyond the island itself. Guam is one of the most militarily significant pieces of territory the United States holds anywhere in the world. It anchors the country's entire presence across the Western Pacific, hosting major installations, ports, and airfields. Thousands of service members, contractors, and their families are woven into the island's population and its daily life. When a Category 5 strength storm approaches Guam, it is not only threatening a civilian community, it is threatening infrastructure that the entire nation relies upon, facilities whose damage would send ripples far beyond the shores of the island itself. The stakes of Bavi are local and national at the very same time. But I do not want the strategic importance to eclipse the human one, because for the families who live there, Guam is not a strategic asset. It is home. It is where their grandparents were born, where their children go to school, where generations of Chamorro people, the indigenous people of the Marianas, have lived for thousands of years. The culture of these islands is old and rooted, and the people who carry it are now facing the possibility of losing homes and landmarks that hold not just their present, but their long history. When a storm like this damages an island community, it damages more than buildings. It threatens the physical fabric of a people's continuity. That is part of what is at risk this weekend, and it is a part that rarely makes it into a forecast. Let me return to that figure of 200,000 and make sure it is fully grounded, because I do not want it to be a number I simply assert at you. Guam is home to roughly 150,000 people, the Commonwealth of the Northern Mariana Islands, which includes Saipan, Tinian and Rota, adds roughly another 47,000. Together they come to very nearly 200,000 United States citizens and nationals living directly in the region that Bavi now threatens. These are not tourists or transient visitors passing through. These are permanent communities with schools and hospitals and churches and small businesses, with all the fragile machinery of ordinary life that a Category 5 storm is built to tear apart. And I want to name the attention gap directly, because it is a real and recurring injustice. When these islands are struck, the coverage on the mainland is often thin and brief. A single news cycle, if that, before the country's attention moves on. The reasons are partly geographic, the sheer distance, the time difference, the fact that these communities sit across the international date line, where the mainland rarely thinks to look. But the effect is that Americans in the Marianas often endure disasters in relative silence, their losses underwitnessed by their own countrymen. I am telling you about Bavi in this much detail precisely to push against that pattern. These 200,000 people deserve the same attention, the same concern, the same national solidarity that we would extend without a second thought to a coastal city on the mainland facing the same storm. For now, keep your eyes on the essential fact. 200,000 of our fellow citizens are inside the projected path of a Category 5 strength storm, on islands with nowhere to run, and the watches went up only overnight. That is the situation as it stands this morning. But to understand why it escalated so fast, why we went from a distant forecast yesterday to active watches today, you have to understand the single most frightening thing a tropical system can do. You have to understand rapid intensification, and Bavi is doing it right now. Part 3. The word that changes everything. There is a term that tropical meteorologists use with a kind of quiet dread, and that term is rapid intensification. On paper it sounds technical, almost bloodless. The formal definition is an increase in a storm's maximum sustained winds of at least 30 knots, about 35 miles per hour, within a 24-hour period. But behind that clean little definition is the single most dangerous behavior a tropical cyclone is capable of, and it is the behavior that Bavi is displaying right now, tonight, east of Guam. Let me explain why forecasters fear it so much, because once you understand the mechanism, you will understand why the watches for those 200,000 Americans went up overnight rather than over the course of a calm, orderly week. When a storm intensifies slowly, everyone has time. The forecasters have time to refine their models. The emergency managers have time to stage supplies and open shelters. The families have time to board up, to buy water, to decide whether to stay or go. Slow intensification is frightening, but it is legible. You can see it coming from a long way off. Rapid intensification steals all of that time at once. A storm that looks manageable when you go to sleep can be a monster by the time you wake up. And that is not a hypothetical. That is very close to what just happened with Bavi over the last day. Walk back through the timeline with me, because the timeline is the whole point. Yesterday morning, this system had 1 minute sustained winds of around 45 miles per hour. By later in the day, those winds had climbed to around 60 miles per hour. That alone is a meaningful jump. But the forecast attached to it was far more alarming than the current readings, because the models and the forecasters could see the environment the storm was moving into. and they projected that Bavi would continue to strengthen, potentially reaching a super typhoon peak near 155 miles per hour within days. And now, this morning, the National Weather Service is describing a storm expected to bring winds near 150 knots. Do that conversion again. 150 knots is about 172 miles per hour. In roughly 48 hours, this storm is forecast to go from a strong tropical storm to a Category 5 equivalent super typhoon. That is not gradual. That is a storm nearly quadrupling the destructive character of its winds in the span of 2 days. And here is the physics that makes rapid intensification so hard to live with, so hard to prepare for. The destructive power of a storm's wind does not increase in a straight line as the wind speed climbs. It increases far faster than that. The energy carried in the wind scales with the cube of its speed. What that means, in plain terms, is that a small increase in wind speed produces an enormous increase in the damage that wind can do. A storm that doubles its wind speed does not do twice the damage. It does something closer to 8 times the damage. So when Bavi rapidly intensifies from a storm with winds around 60 miles per hour to a storm with winds near 170, the destructive potential has not grown by a factor of 3. It has exploded by a factor many times larger than that. Rapid intensification is not just the storm getting stronger, it is the storm getting catastrophically more dangerous while the clock runs out for the people in its path. This is precisely why the escalation from yesterday to today matters so much, and why I keep pulling us back to it. Yesterday there were no watches because yesterday the storm was still far away and still building. Today the watches are up because today the storm is doing the thing forecasters fear most, and doing it on a direct approach to American islands. The 200,000 people I keep talking about did not get a slow, gentle warning that built over a week. They got the compressed version. They got the version where the threat sharpens overnight. Now, why is Bavi able to do this? Why here? Why now? A storm cannot rapidly intensify just because it wants to. It needs a very specific set of conditions all lined up at once, like tumblers in a lock clicking into place. It needs warm ocean water, and not just at the surface but running well below it. It needs the winds high in the atmosphere to be gentle, so they do not tear the growing storm apart. It needs the storm to be able to vent the air it pulls in, exhausting it out the top efficiently. When all of those conditions align, a tropical system can behave less like weather and more like a heat engine running at full throttle, converting the warmth of the ocean into wind at a ferocious rate. And the patch of ocean that Bavi is crossing right now, the Philippine Sea east of Guam, is one of the most reliable places on the entire planet for all of those tumblers to click into place at the same time. History is full of storms that taught this lesson in the cruelest way, and the pattern repeats often enough that forecasters have learned to fear it on sight. Time and again, a tropical system that looked ordinary or even weakening in the evening has exploded overnight into a top-tier monster by the time it reached land the next day, arriving far stronger than the warnings that preceded it. Communities that had prepared for a manageable storm were suddenly facing a catastrophic one, with the strongest winds ashore before the updated warnings could fully change what people had already decided to do. The storms did not break any rules of physics. They simply found the perfect environment, that combination of very warm water running far below the surface, gentle winds aloft, and clean outflow, and they took full advantage of it in the span of a single night. That is exactly the environment Bavi is sitting in right now. Understand why this is so hard to forecast, because the difficulty is not a failure of the forecasters, it is a genuine limit of the science. The onset of rapid intensification depends on small-scale processes far inside the storm's core. The exact arrangement of the thunderstorms around the eye, the precise structure of the inner circulation, details that are extremely difficult to observe and even harder to predict hours in advance. Forecasters can identify when the large-scale environment is favourable for rapid intensification, as they did with Bavi. But pinpointing the exact moment it begins and exactly how far it will go remains one of the great unsolved challenges of tropical meteorology. So they do the responsible thing. When the environment is primed, they warn early and they warn strongly, because they would rather prepare people for a monster that does not fully materialise than be caught flat-footed by one that does. That is precisely the posture the forecasters took with Bavi. They saw the environment. They saw a storm sitting in the perfect conditions for explosive growth. And rather than wait for the intensification to be fully underway before sounding the alarm, they issued the watches while the storm was still building, widened them to cover more of the island chain, and put the Category 5 projection on the table. They are treating Bavi as the monster it is forecast to become, not merely the storm it was yesterday, because they know how fast the transformation can happen and how little time it would leave for 200,000 people to react. That decision, to warn ahead of the intensification rather than behind it, is exactly what the history of these storms demands. That is the machine we have to understand next. Because you cannot make sense of why a storm is exploding toward 200,000 Americans without understanding the specific stretch of ocean that is feeding it. And once you see how that machine works, you will understand not only why Bavi is strengthening, but why our ability to measure exactly how strong it is getting is dangerously limited. Let me show you the factory. Part 4. The factory. The stretch of ocean that Bavi is crossing right now has a reputation among the people who study storms for a living, and that reputation is not a friendly one. The Philippine Sea, and in particular the warm expanse of it that sits to the east and south of the Mariana Islands, is one of the most productive breeding grounds for extreme tropical cyclones anywhere on the planet. When forecasters talk about it, they sometimes call it a super typhoon factory, and that is not hyperbole. It is a description of what this water reliably does. It takes tropical storms and it turns them into monsters. Bavi is simply the latest system to be fed into it. Understand first that a tropical cyclone is, at its core, an engine that runs on heat. It draws warm, moist air up from the surface of the ocean. That air rises and cools and releases its moisture as rain, and in the process it dumps enormous amounts of energy into the storm, energy that becomes wind. The warmer the water, the more fuel the engine has. And the water Bavi is crossing right now is running at roughly 29 to 31 degrees Celsius. In the temperature scale most Americans use, that is around the mid-80s Fahrenheit, warm enough to swim in comfortably, and far more than warm enough to power a catastrophe. Tropical cyclones generally need sea surface temperatures of at least 26.5 degrees Celsius to form and sustain themselves. Bavi is crossing water several degrees warmer than that minimum, which is like handing the engine a richer and richer fuel with every mile it travels. But surface temperature alone is only half the story, and this is the part that separates an ordinary storm from a rapidly intensifying one. What matters even more is how far down that warmth extends below the surface. In many parts of the ocean, the warm layer is thin. A storm churns the water as it passes, it drags cooler water up from below, and that cooler water acts as a brake, starving the engine and capping how strong the storm can get. But in the Philippine Sea right now, the warm water runs far below the surface, layer upon layer of it. When Bavi churns the ocean beneath it, it does not pull up a cold break, it pulls up more warmth. The fuel does not run out. That reservoir of warmth stored well beneath the surface is the single most important ingredient in explosive intensification, and this patch of ocean has it in abundance. Now add the air above. For a storm to strengthen, the winds high in the atmosphere have to be relatively gentle and uniform. If the winds up top are blowing much faster, or in a different direction than the winds down low, they shear the storm, they tilt it and tear at its structure, and prevent it from organizing into a tight, efficient core. Think of it like trying to build a spinning tower of warm air. If a crosswind is constantly pushing the top of the tower off of its base, the whole thing wobbles and falls apart. But if the winds aloft are calm, the tower can stand straight and spin faster and faster. Right now, in Bavi's environment, that vertical wind shear is low. The tower can stand, and the storm is taking full advantage. There is one more piece, and it is the exhaust. A tropical cyclone is constantly pulling air in at the bottom, and all of that air has to go somewhere. It rises through the core and it has to be vented out the top, flung away from the storm high in the atmosphere, or else the whole system backs up and chokes. When the outflow at the top of the storm is strong and unobstructed, the engine breathes freely and it can pull in more and more air at the surface, spinning up its winds. Bavi has that clean exhaust right now. It is inhaling warm ocean air at the bottom and exhaling it efficiently at the top, and every cycle of that breathing tightens the core and lifts the wind speed. Put all of these together, the exceptionally warm surface, the warmth running far below it, the gentle winds aloft, the clean venting at the top, and you have every tumbler in the lot clicking into place at once. This is why the forecasters were so worried yesterday, even when the storm's winds were only around 60 miles per hour. They were not looking at what Bavi was. They were looking at what the environment would allow it to become, and the environment is nearly ideal for catastrophe. This is the factory doing what the factory does. It is turning a strong tropical storm into a Category 5 strength super typhoon, and it is doing it on a direct approach to the 200,000 Americans in the Mariana Islands. Let me push the heat engine picture a little further, because the more precisely you see it, the more you understand why this particular ocean is so dangerous. A tropical cyclone works by taking heat from the warm sea surface at the bottom and carrying it upward, releasing it high in the cold upper atmosphere, and converting the difference between those two temperatures into mechanical energy, into wind. The larger that temperature difference, the more efficient the engine. Over the Philippine Sea in early July, the surface is exceptionally warm, while the upper atmosphere stays cold, and that wide gap between the warm bottom and the cold top is precisely what allows the engine to run at high efficiency. Bavi is not just sitting over warm water, it is sitting over warm water beneath a cold sky, which is the ideal configuration for turning ocean heat into destructive wind. Humidity plays its own quiet role in all of this. For the engine to run, the air being drawn up through the storm has to be laden with moisture, because it is the condensation of that moisture into rain, high in the clouds, that releases the enormous latent heat which powers the whole system. The air over this stretch of ocean is thick with moisture, saturated by the warm sea beneath it. Every parcel of air that spirals into Bavi's core is carrying a heavy load of water vapour, and every bit of that vapour becomes fuel when it condenses. This is why a storm over a warm, humid ocean can intensify so explosively. It is not just warm water, it is warm water feeding warm, wet air into an efficient engine under a cold sky, all at once. Now understand that this specific patch of ocean has done this before, again and again. The Western Pacific is, by a wide margin, the most prolific producer of the planet's most intense tropical cyclones. More Category 5 equivalent super typhoons form here than in any other ocean basin on Earth. The all-time record holder, the storm I will tell you about later, formed here. Many of the strongest storms ever measured formed here. This is not an ocean that occasionally produces a monster. It is an ocean that produces them reliably, as a matter of routine, and the Mariana Islands sit right in the middle of the corridor those storms travel. The people who live there have always known this. It is written into their architecture, into their emergency plans, into the collective memory of communities that have faced these storms for generations. What has changed, and what makes tonight different, is the combination of that reliable factory with the warmed baseline I will come to shortly, and with our diminished ability to precisely measure what the factory produces. The Philippine Sea has always been capable of building monsters, but it is building them now over water that is running warmer than it used to, and it is handing them to a monitoring system that, for these storms, no longer flies aircraft into their cores. The factory is the same factory it has always been, only hotter, and the people downwind are watching its output through a narrower window than they once could. That combination is the reason a storm like Bavi can escalate from a distant forecast to an active Category 5 threat in the span of a single day, with the exact strength still uncertain even as the watches go up. And this is exactly where the story takes its most unsettling turn. Because everything I have just described to you, the warm water, the low shear, the strong outflow, the projected peak near 150 knots, all of it rests on measurements. And in this particular corner of the world, the way we measure the strength of a storm is far more fragile, far more uncertain than most people realize. We're watching a monster grow in the Philippine Sea, and the truth is that we're watching it through a keyhole. Let me show you what I mean, because this is the part of the story that should genuinely give you pause. Part 5. Watching through a keyhole. Here is something most people simply do not know, and once you learn it, you may never look at a storm forecast the same way again. When a hurricane threatens the United States mainland or the Caribbean, we do not just guess at how strong it is. We fly into it. The famous hurricane hunters, specially built aircraft operated by the government, fly directly into the core of Atlantic hurricanes, releasing instruments that fall through the storm and radio back precise measurements of pressure and wind. When you hear that a hurricane approaching Louisiana has winds of 140 miles per hour, that number is very often a measured number, taken by an aircraft that flew into the eye and read the storm's vital signs directly. In the Western Pacific, where Bavi is intensifying right now, those flights do not happen. There is no routine hurricane hunter reconnaissance over the storms that threaten Guam and the Mariana Islands. The aircraft program that once flew these Western Pacific systems was ended decades ago. So when forecasters tell us that Bavi has winds near 150 knots, They are not reading that number off of an instrument that flew through the eye an hour ago. They are estimating it. And the primary way they estimate it is a technique that, remarkable as it is, comes down to looking at pictures from space and matching patterns. That technique has a name. It is called the Dvorak technique, and it has been the backbone of tropical cyclone intensity estimation for decades. The idea behind it is genuinely clever. Over many years, meteorologists noticed that the appearance of a storm in satellite imagery, the shape of its cloud pattern, the symmetry of its spiral bands, the character of its eye, the temperature of the cloud tops, all of these correlate with how strong the storm actually is. So they built a systematic method for looking at a satellite image, scoring these features, and translating that score into an estimate of the storm's intensity. It is a brilliant piece of work, and for storms where we cannot fly aircraft, it is very often the best tool we have. But I want you to hold on to the word estimate, because it is doing enormous work here. When you determine a storm's strength by matching the pattern of its clouds to a catalogue of what past storms of known strength looked like, you are making an educated inference, not a direct measurement. And at the very top end of the scale, where Bavi is now climbing, that inference gets shakier, not steadier. The most extreme storms are precisely the ones we have the fewest historical examples of, precisely the ones where small differences in cloud appearance can correspond to large differences in actual wind speed. A storm that the satellite scores at 150 knots could, in reality, be somewhat weaker, or it could be meaningfully stronger. The honest answer is that until the storm is close enough for other kinds of measurements, or until it actually passes over an island with working instruments, we do not know its true strength with the precision that number implies. Think about what that means for the 200,000 people in Bavi's path. They have been handed a number, 150 knots, Category 5 equivalent, and they are preparing their lives around it, and that number is the best estimate available from the finest tools we have for this ocean. But it is an estimate derived from a camera in space and a decades-old method of pattern matching. The people in Saipan and Guam are not being lied to. They are not being kept in the dark by anyone, but they are being asked to prepare for a storm whose exact ferocity cannot be pinned down until it is nearly upon them, because the aircraft that could pin it down are not flying here. That is the keyhole I am talking about. We are watching one of the most dangerous storms on Earth grow toward American soil, and we are watching it through a narrow, imperfect window. It is worth understanding just how much rests on this one technique, and how it came to be. The Dvorak method was developed decades ago, in an era when satellite imagery was becoming widely available, but computing power and other observing tools were far more limited. Its genius was to turn the subjective art of looking at a storm into a repeatable, systematic procedure that any trained analyst could apply and arrive at a similar answer. Over the years, it has been refined and partly automated, and it remains remarkably useful. For a great many storms in oceans where no aircraft fly, it is the foundation of everything we think we know about how strong they are. But it was never meant to be as precise as a direct measurement, and its designers would be the first to say so. It is a best available inference, and its accuracy is at its shakiest for the very strongest storms, the ones with the fewest historical examples to calibrate against. There are other tools that help, and I want to be fair to the full picture, because it is not as if forecasters are working from a single grainy photograph. Satellites carry instruments that can peer through the clouds using microwave sensors, revealing the structure of the storm's core in ways ordinary imagery cannot. Other satellites can estimate the surface winds by reading the texture of the ocean itself. These tools add real information, and forecasters weave them together with the Dvorak estimates to build the best picture they can. But every one of these methods is still a form of remote sensing, still an inference from a distance, and each has its own gaps and blind spots, particularly at the extreme upper end of intensity. None of them is the same as an aircraft flying into the eye and dropping an instrument that measures the pressure and wind directly. That gold standard simply is not being applied to these Western Pacific storms. Why did the aircraft stop flying here? The routine reconnaissance of Western Pacific typhoons was discontinued decades ago, a decision driven by cost and by the changing priorities of the time, back when satellite methods were thought sufficient to fill the gap, and for many purposes they are. But the consequence is that the part of the world that produces the planet's most intense tropical cyclones, the part of the world where 200,000 Americans live directly in the storm corridor, is also the part of the world where our intensity measurements are the least direct. We fly into the storms that threaten the mainland and the Caribbean, and we estimate from space the storms that threaten Guam and the Marianas. There is an uncomfortable asymmetry in that, and Bavi is placing it in sharp relief. I want to be careful and honest here, because this is exactly the kind of gap that gets twisted into something it is not. When people hear that we cannot measure a storm precisely, that we are estimating its strength from satellite pictures, some immediately leap to the idea that someone is hiding the truth, that the real numbers are being concealed. That is not what is happening, and I will address that thinking directly later in this briefing. The reality is almost the opposite of a cover-up. The forecasters are openly telling us about the uncertainty. They are the ones who built the Typhoon Watch, who widened it to the Northern Islands, who put the 150-knot figure on the table, while knowing full well the limits of how it was derived. The blind spot is not a secret. It is a known limitation of the tools, and the professionals are being transparent about it. But knowing that it is not a conspiracy does not make it comforting, because the core mystery of this entire event flows directly out of this keyhole. How strong will Bavi actually be when it reaches those 200,000 Americans? The truth is that we are estimating it from space, and the estimate says Category 5, and the storm is still in the middle of the ocean feeding on warm water with nothing to slow it down. The uncertainty does not cut only toward it being weaker than we think. It cuts both ways, and that is why the next question, the question of exactly where this storm is going and when it will arrive, carries so much weight, because on islands this small, a shift of just a few dozen miles in the track is the difference between a near miss and a direct hit. Let me walk you through what the forecast maps are actually showing. Part 6. A few dozen miles. When a storm is bearing down on a continent, the exact track matters, but there is a margin for error built into the sheer size of the land. If a hurricane aimed at the Gulf Coast comes ashore 50 miles east or west of where it was forecast, that is a serious matter, but it still comes ashore over land, over people, over the same broad stretch of coastline. When a storm is bearing down on islands the size of Saipan or Tinian, there is no such margin. These islands are only miles across. A shift of a few dozen miles in the track is not a minor adjustment. It is the entire difference between the eye passing directly over a community and the eye passing harmlessly out to sea. And right now, the models that forecast Bavi's path do not fully agree. Let me lay out the disagreement, because it is the crux of the uncertainty tonight. The major forecast models take the general consensus that Bavi is heading west-northwest toward the Marianas, and then they diverge on the details in a way that matters enormously to the people below. One of the primary American models has favoured a track that carries the storm toward Tinian and Saipan, the more central and northern of the populated islands. Another of the world's leading models, the European one, has favoured a track a bit farther south, one that would bring the storm closer to Rota and Guam before it curves away into the open Philippine Sea. Both of these solutions put the core of a Category 5 strength storm dangerously close to populated American islands. They simply disagree about which islands are most directly in the crosshairs. I cannot overstate how consequential that disagreement is for the families living on those specific islands. If you are on Saipan tonight, one respected model is telling you the core may come for you, and another is telling you it may pass to your south. If you are on Guam, the situation is reversed. And because we already know that our ability to measure the storm's strength is limited by the satellite-only keyhole, this track uncertainty layers a second unknown on top of the first. We are not fully certain how strong Bavi will be, and we are not fully certain exactly which islands its worst winds will cross. What we're certain of is that somewhere in that chain of American islands, a very powerful storm is going to make a very close approach, and everyone in the chain has to prepare as if they are the ones in the centre of the target. Now let me give you the timing, because the timing is what turns all of this from an abstract forecast into an urgent countdown. The impacts from Bavi are expected to arrive around Sunday, July 5th, and into Monday, July 6th. The forecasters are urging that preparations be completed by Saturday, July 4th. Read those dates again and feel the weight of them. The deadline to be ready is the 4th of July. 200,000 Americans are being told that their window to secure their homes, stock their supplies, and get to safety closes on the nation's holiday because the storm is coming the day after. There will be no fireworks weekend for the Mariana Islands. There will be plywood and generators and the particular dread of watching a monster approach across the radar, and the rain will arrive with the wind. The forecast calls for storm total rainfall on the order of 10 to 18 inches across the affected islands. I talked earlier about what that volume of water does to small islands with steep terrain, but it bears repeating in the context of timing, because the rain does not wait for the peak winds. It arrives ahead of the core, and it lingers behind it, saturating the ground, swelling the streams, loosening the hillsides. By the time the strongest winds arrive, the land itself is already waterlogged and unstable, and trees that might have stood against the wind on dry ground come down more easily when their roots are sitting in saturated soil. The rain and the wind and the surge do not act as three separate threats. They compound one another, each one making the others deadlier. Think about what that compressed timeline does to the human decisions on the ground. Preparation is not a single action, but a long sequence of them, and each one takes time. Securing a home, gathering supplies, fueling vehicles and generators, deciding whether to shelter in place or move to a public shelter, helping neighbours and relatives who cannot manage on their own, all of it has to happen before the first dangerous bands of the storm arrive. When the deadline to complete that sequence is the 4th of July, and the impacts begin the very next day, there is precious little slack in the schedule. A family that waits even a few hours too long, that assumes there is more time than there is, can find the window closing on them. This is why the forecasters have been so insistent about the Saturday deadline, and why the escalation of the watches overnight matters so much. Every hour of early warning is an hour that can be spent preparing rather than scrambling, and on islands with no escape route, that preparation is the whole of the defence. There is a projected peak in all of this, a moment forecasters have circled. The Joint Typhoon Warning Centre has pointed toward a peak intensity near 155 miles per hour around July 5th, with the storm potentially passing just south of Tinian in the window, around late on July 5th into the early hours of July 6th local time. If that projection holds, Bavi would be a candidate for the strongest July typhoon to make a direct pass at the Mariana Islands in the reliable record. Let that sink in. Not the strongest this year, not the strongest this decade, a candidate for the strongest July storm to directly threaten these islands in the entire span of our reliable records. That is the ceiling this system is reaching for, and it is doing it on a holiday weekend, aimed at Americans, through the keyhole of our limited ability to measure it. Let me explain a little more about why the models disagree, because understanding the source of the uncertainty helps you understand why the forecasters cannot simply pick the right answer and be done with it. A forecast model is an enormous computer simulation of the atmosphere, fed with millions of observations and run forward in time according to the laws of physics. But the atmosphere is chaotic, meaning that tiny differences in the starting conditions, differences smaller than we can even measure, grow over time into large differences in the outcome. To cope with this, forecasters do not run a model just once. They run it many times, each with slightly different starting conditions, and they look at the spread of the results. When those many runs cluster tightly together, confidence is high. When they fan out, as some of Bavi's guidance has, it is a signal that the atmosphere is in a state where small unknowns will have large consequences. That is exactly the situation for the track through the Marianas. The core of the uncertainty is the steering ridge, that broad area of high pressure to the storm's north whose strength and position determine where Bavi goes. If the ridge stays strong and extends far to the west, it acts like a wall, forcing the storm to keep moving on a more westerly heading, further toward the central islands. If the ridge weakens or retreats sooner than expected, it opens a gap, and the storm begins to feel the pull toward the north earlier, shifting its track. The models disagree precisely because they disagree by small amounts about what that ridge will do over the coming days, and those small disagreements about the ridge translate directly into the difference between the core crossing Tinian and Saipan, or passing south toward Rota and Guam. A few dozen miles of difference in the ridge becomes a few dozen miles of difference in the track, which on islands this small becomes the difference between everything and nothing. There is also a longer range dimension to the track that is worth naming, because Bavi's story does not end at the Marianas even in the forecast. After it passes the islands, the guidance carries the storm on into the wider Philippine Sea, and the longer range possibilities open toward the west and northwest, toward Luzon in the northern Philippines, toward Taiwan, and potentially further out toward Japan. Those longer-range tracks are far more uncertain than the near-term threat to the Marianas, and I raise them not to alarm anyone in those places tonight, but to make a point about the scope of this system. Bavi is not a threat to one island for one day. It is a large and powerful storm that will be a factor in the Western Pacific for a week or more, and its story will continue to unfold well after this weekend, potentially affecting tens of millions of additional people down the line. But the near term, the certain part, the part that demands action tonight, is the Marianas. Whatever Bavi does afterward, its first and most immediate encounter with populated land is the American island chain, and that encounter is coming this weekend. The track uncertainty does not change that. It only changes which of those American islands will bear the worst of it, and that is a question we may not be able to answer with confidence until the storm is nearly on top of them. This is the second layer of unknowing I keep coming back to, stacked on the first. We are uncertain how strong Bavi will be, because of the satellite keyhole, and we are uncertain exactly where it will strike hardest, because of the chaotic dance of the steering ridge. Two unknowns, layered one on top of the other, over the heads of 200,000 people who have to prepare as though each of them, individually, is in the exact centre of the target. So this is the situation on the maps tonight. A storm of Category 5 potential, its exact track still splitting between the central islands and the southern ones, its arrival timed for Sunday into Monday, its preparation deadline falling on the 4th of July itself. The countdown is running for 200,000 people, but numbers on a forecast map, even numbers this frightening, can feel abstract until you connect them to what a storm like this actually does when it arrives, and to what these particular islands have already survived. Because Bavi is not approaching a community that has never seen the ocean turn violent. It is approaching one that is still, right now, digging out from the last time, and that is a story I have to tell you carefully. Part 7. What a wall of water actually does. I have thrown a lot of numbers at you tonight, and I want to take one of them and make it real, because it is the number that will do the most damage and the one that is hardest to picture. Seas up to 45 feet. That is the forecast for the waters around the Mariana Islands as Bavi approaches. 45 feet is not a wave you ride out. It is not a rough day at the beach. It is a wall of moving water taller than a 4-story building, and when that water is driven by a Category 5 strength storm onto a small island, with communities living right along the shore, the results are exactly as bad as your instincts are telling you they are. Let me separate out the different ways this storm will attack, because they are distinct, and understanding them tells you why a system like Bavi is so much more than just strong wind. The first threat is the wind itself. Sustained winds near 170 miles per hour with gusts pushing past 200 are almost beyond the scale of ordinary experience. At those speeds, wind stops being something that pushes against a building and starts being something that dismantles it. Roofs are peeled away, walls that are not engineered to the highest standards fail. Windows shatter under flying debris, and once the wind gets inside a structure, the pressure difference can lift the roof off from within. Anything not tied down becomes a projectile. Vehicles are pushed and rolled. Trees are not just knocked over but stripped and snapped. This is the kind of wind that changes the shape of the land in a matter of hours. The second threat is the one that historically kills the most people in these storms, and it is the storm surge. When a powerful tropical cyclone approaches land, its winds and its low pressure pile the ocean up ahead of it, pushing a dome of seawater toward the shore. When that dome arrives, it does not come as a single dramatic wave. It comes as a rapid, relentless rise in the sea level, water pouring inland far beyond the normal reach of the tide, carrying everything with it. On the small, low-lying stretches of these islands, where so many people live and work close to the water, storm surge can inundate entire communities. And when you layer 45-foot seas on top of that surge, when you add battering waves riding on top of an already elevated ocean, the destructive reach extends even farther inland and even higher up the shore. The surge is what turns a wind event into a drowning one. The third threat is the rain, and I have already told you the figure, 10 to 18 inches of it. On flat land, that much rain is a flood. On the steep volcanic terrain of these islands, it is something more dangerous. Water runs downhill fast, gathering into torrents, overwhelming streams and drainage, and undercutting slopes until they give way. Landslides become a serious risk. Roads become rivers. And critically, the rain arrives before and during the worst of the wind and surge, so all three are happening at once. A family is not asked to survive the wind, and then the surge, and then the flood, in an orderly sequence. They are asked to survive all three at the same time in the dark, cut off from help. And this is the point I most want you to hold on to, because it connects everything back to the core of tonight's story. On an island, there is no meaningful escape from any of this. On the mainland, you can drive inland, away from the surge, out of the worst of the wind. On Saipan or Tinian or Guam, there is no inland far enough. The entire island is the coast. When a storm this size arrives, every part of the land is exposed to some combination of wind, surge, and flooding. The 200,000 Americans in Bavi's path cannot outrun it by road. Their only options are to shelter in the strongest structures available and to endure. That is what makes a Category 5 approach to small islands so uniquely terrifying, and it is why the forecasters widened those watches and moved the preparation deadline up to the 4th of July. There is no room for error when there is nowhere to go. Let me stay with the surge for a moment longer, because it is the threat people most often underestimate, and understanding it could genuinely save a life. Most people, when they imagine a storm hitting the coast, picture the wind first. But historically, across these kinds of storms worldwide, it is the water that kills the most people, and the storm surge is the deadliest form that water takes. The reason it is so lethal is that it arrives fast and it arrives heavy. Seawater weighs a great deal, roughly 1.5 tons per cubic yard, and when a wall of it moves inland, it does not simply rise gently around your ankles. It moves with force, strong enough to sweep cars off roads, to knock buildings from their foundations, to carry away anything and anyone not on high, solid ground. A person cannot outrun it, and often cannot even stand in it once it is more than a couple of feet high and moving. Now put that surge on the geography of these islands. On a flat mainland coast, surge spreads out and its energy dissipates over distance. But around islands, the shape of the seafloor and the shoreline can focus and amplify the water, funneling it into bays and low-lying stretches where it piles higher than it would on an open coast. Layer onto that the 45-foot seas the forecast describes, the battering waves riding on top of the elevated water, each one hammering structures already under assault, and you have a coastal environment that becomes, for a period of hours, simply uninhabitable. The only defence is elevation and distance from the shore, and on small islands both of those are in short supply. This is why local emergency officials, not me, are the voices to heed, because they know exactly which neighbourhoods sit lowest and which shelters sit highest. Consider too what all of this asks of the buildings themselves. A well-engineered modern structure built to a strict code with reinforced connections and impact-rated windows has a real chance of coming through even a very powerful storm intact. But not every building on these islands is a fortress, and the older, weaker or already damaged structures are the ones that fail first. When the wind finds a weak point, a poorly secured roof, an unprotected window, it exploits it, and once the building is breached, the wind gets inside and the pressure can tear the structure apart from within. This is why the guidance is not simply to stay home but to shelter in the strongest available structure, and why public shelters exist, because for many families the safest choice is to leave a vulnerable home for a building specifically hardened to withstand exactly this. And here is the compounding I keep emphasizing made concrete. A family on one of these islands this weekend will not face the wind, then the surge, then the rain, in a neat sequence with time to recover between them. They will face all three at once, in the dark, with the power out, with the phones possibly down, cut off from any outside help until the storm passes and the long, difficult work of reaching isolated communities can begin. Every one of those threats makes the others worse. The rain saturates the ground so the wind topples more trees. The wind drives the surge higher up the shore. The surge and flooding block the roads that emergency responders would use. This is the full weight of what a Category 5 strength storm brings to a small island, and it is what 200,000 Americans are being asked to prepare for, on a deadline, with the exact severity still uncertain. Now hold all of that in your mind. The wind that dismantles, the surge that drowns, the rain that buries, the island with no escape, and then add the cruelest variable of all. Imagine facing that storm not from a position of full strength, but while you're still repairing the damage from the last one. Because that is precisely where Saipan and Tinian stand tonight. This is not their first monster of the year, and to understand what Bavi truly means for these communities, you have to understand what already happened to them just months ago. Part 8. The Ghost of the Last Storm. Earlier this year, before Bavi was even a name on a list, another powerful storm came for these same islands. Its name was Sinlaku, and when it swept through the Marianas in the spring, it left Saipan and Tinian battered. Homes were damaged, infrastructure was knocked down. The long, grinding work of recovery began, the work that never makes the national news on the mainland, the work of families repairing roofs, of communities restoring power and water, of an economy trying to find its footing again after the ocean has taken a swing at it. That work is not finished. Months later, parts of these islands are still rebuilding from Sinlaku, and now Bavi is bearing down on them. I want to slow down here, because this is the human core of the entire story, and it is easy to lose it in the physics and the forecast maps. When we talk about a storm hitting a place that is already damaged, we are not talking about a statistical inconvenience. We are talking about people who have spent months of their lives putting things back together, who have drained their savings on repairs, who have finally gotten a tarp replaced with a real roof, or a downed line reconnected, and who now have to watch a Category 5 strength storm approach the very repairs they just made. The exhaustion of that, the psychological weight of it, is something that does not show up in any wind speed or pressure reading, but it is absolutely real, and it is being felt across these islands right now. Consider what it does to a community's resilience, in the most practical terms. When a storm hits a fully recovered, fully resourced place, that place has its full strength to absorb the blow and respond. Emergency supplies are stocked, infrastructure is intact and at its designed strength. People are rested. But when a storm hits a place that is still recovering from the last one, all of those margins are already spent. Building materials that would have gone into new construction were used up patching the old damage. Emergency reserves that would have been full are partly depleted. Structures that were weakened by Sinlaku and only partially repaired are now being asked to stand against something even stronger. Every measure of a community's ability to withstand a disaster is diminished when it is hit again before it has healed. Bavi is not arriving at a community at full strength. It is arriving at one that is already worn down. Let me make the recovery from Sinlaku concrete, because the word rebuilding can slide past you without landing. After a major storm strikes an isolated island, the work of putting it back together is unlike recovery almost anywhere on the mainland. Every sheet of plywood, every roll of roofing, every replacement generator, every pallet of building supplies has to be shipped or flown across thousands of miles of open ocean before it can even reach the island, let alone the neighborhood that needs it. That means recovery moves slowly, at the speed of ships and cargo planes, and it means the supplies are limited and precious. Months after Sinlaku, that pipeline is still running, still delivering the materials to repair what the spring storm broke. Some families are living under temporary repairs, some public buildings are not yet fully restored. The island had not finished healing when Bavi appeared on the horizon. Now imagine being one of those families this week. Imagine having spent months and much of your savings repairing the damage from one storm, only to watch the forecast fill with the cone of another one, stronger than the last, aimed at the very repairs you just made. The emotional weight of that is real, and it is heavy. It is one thing to brace for a disaster when you are whole and rested. It is another thing entirely to brace for one while you're still exhausted from the last, while the tarp is still on part of the roof, while the insurance claim from the spring is not yet settled. That specific kind of exhaustion, the exhaustion of a community hit twice before it could recover once, does not appear in any wind speed or pressure reading, but it shapes everything about how these 200,000 people will experience Bavi, and it is a large part of why the escalation from a distant forecast to an active watch lands so heavily here. There is also a practical dimension to being struck while still recovering, and it is dangerous in its own right. A structure that was weakened by Sinlaku and only partly repaired is more likely to fail under Bavi's winds than one that was whole. Debris left over from the earlier storm, if not fully cleared, becomes ammunition for the new one. Emergency resources that would ideally be fully stocked are partly spent. Every margin that a community relies on to survive a disaster is thinner the second time around, when the first blow has not fully healed. This is the compounding vulnerability of back-to-back storms, and it is exactly the situation the Marianas find themselves in tonight, which is why the honest guidance is to treat Bavi as an even more serious threat to these already battered islands than the raw numbers alone would suggest. And there is a grim pattern here that deserves to be named honestly, without exaggeration. These islands sit in one of the most active tropical cyclone regions on Earth. They have always faced storms, but when the ocean is running as warm as it is now, when the factory I described is operating at full capacity, the storms that emerge from it can be more intense, and rapid intensification can make more of them dangerous. A community that once might have faced one serious storm in a season can find itself facing two, back to back, before it has had time to recover from the first, Sinlaku in the spring, Bavi in the summer. The gap between disasters is not always long enough for the healing to finish, and that compression, that stacking of blows, is one of the quiet ways that a warming ocean makes itself felt in human lives, not through a single record-breaking event, but through the relentless frequency of serious ones. So when I ask you to think about the 200,000 Americans in Bavi's path, I am not asking you to think about a fresh, undamaged community bracing for a first blow. I am asking you to think about people who are tired, who are still repairing, who are being told that the ocean is coming for them again, and who cannot leave. That is the human stakes of this storm, and it is exactly why the escalation from a distant forecast yesterday to active watches today matters so much. Every hour of warning is precious to a community that is starting from behind, and every bit of uncertainty in how strong Bavi will be, uncertainty that flows from the satellite-only keyhole we talked about, is uncertainty that makes it harder for already exhausted people to know how hard to brace. There is a larger question hiding underneath all of this, and I want to face it directly, because it is the question that turns Bavi from a single storm into part of a pattern. Why is the ocean producing these monsters so reliably right now? Why is the factory running so hot? Part of the answer is simply that this region always breeds powerful storms, but part of the answer lies in the state of the wider ocean this year, in a set of conditions that has quietly raised the ceiling on what these storms can become. And understanding that backdrop is the key to understanding not just Bavi, but what these islands and coastlines around the world may be facing more and more often. Let me show you what the ocean is doing underneath all of this. Part 9. The Warmed Baseline. To understand why Bavi is able to reach for Category 5 strength so readily, you have to zoom out from this one storm and look at the state of the whole tropical Pacific this year. And the first thing to understand is what it is not doing. There is a natural climate pattern that cycles through the tropical Pacific called El Niño, and its opposite, La Niña, a back-and-forth swing in ocean temperatures that has enormous effects on weather around the world. When forecasters want to know the state of that swing, they look at a measurement of ocean temperature in a key part of the Pacific, expressed as an index. Right now, that index sits at about positive 0.48. That is a neutral reading. We are not in a strong El Niño. We are not in a La Niña. The tropical Pacific is, by that measure, in a middling neutral state. And that is exactly what makes this year so quietly concerning. Because even in a neutral state, even without the extra push of a strong El Niño, the ocean is running warm enough to power a storm like Bavi toward Category 5. The baseline itself has shifted upward. Consider the trajectory of that index over recent seasons. Not long ago, the tropical Pacific was in a cool phase, with the index sitting around negative 0.55. Over the course of roughly 6 seasons, it has climbed steadily, swinging from that cool reading up through neutral to its current value near positive 0.48, and the underlying sea surface temperatures have warmed along with it. What we are watching is not the ocean at the peak of a hot cycle. We are watching the ocean at a neutral point on its cycle, and finding that even neutral is warm enough to be dangerous. This matters because of a concept that sits at the center of how scientists think about the limits of these storms. There is a theoretical ceiling on how strong a tropical cyclone can get in a given environment, a maximum potential intensity set primarily by how warm the ocean is and how the atmosphere above it is structured. Warmer water raises that ceiling. It does not guarantee that every storm will reach it, but it raises the maximum of what is possible. When the baseline ocean temperature climbs, the ceiling climbs with it, and storms that manage to line up all the other favourable conditions, the low shear, the good outflow, the warmth running far below the surface, can reach for a higher peak than they could have in a cooler ocean. Bavi is a storm that has lined up all of those favourable conditions, and it is doing so over an ocean whose ceiling has been quietly lifted. That is a large part of why it can climb so high, so fast. I want to be extremely careful and honest here, because this is precisely the kind of point that gets distorted in both directions. It would be wrong to say that a warming ocean caused Bavi. No single storm can be pinned to the broad state of the climate, and any honest scientist will tell you that attribution of an individual event is a difficult and careful business. Storms have formed and intensified in this region for as long as there has been an ocean here. What the warmed baseline does is not create storms out of nothing. What it does is raise the odds, load the dice, lift the ceiling. It makes the extreme end of the range more accessible. It makes rapid intensification, the very behaviour that stole the warning time from those 200,000 Americans, somewhat more likely to occur because there is more fuel available and the fuel runs deeper. That is the honest framing, and it is unsettling enough on its own without any exaggeration. Think about what this means for the pattern we saw in the last part, the back-to-back blows of Sinlaku and now Bavi. When the baseline is warmer, the season's potential for intense storms is elevated across the board, not just for one storm but for the whole run of them. A community that historically might have caught a break between serious systems finds those breaks getting shorter and less reliable. The warmed ocean does not announce itself with a single obvious signal. It shows up in the accumulation, in the frequency of rapid intensification events, in the number of storms that reach the top of the scale, in the shrinking gaps between disasters for places like the Marianas. Bavi is one data point in that larger pattern, but it is a vivid one because we are watching it happen in real time, aimed at American citizens. Let me give you a clearer picture of what this ceiling actually is, because it is one of the most useful ideas in all of tropical meteorology. Scientists can calculate for any given patch of ocean and atmosphere the theoretical maximum strength a storm could reach there if every other condition were perfect. They call it the maximum potential intensity, and it is set primarily by how warm the ocean is and how the temperature of the atmosphere is arranged above it. Most storms never come close to this ceiling because something, wind shear, dry air, a poor track, holds them back. But the ceiling defines the outer limit of what is possible, and when the ocean warms, that ceiling rises. A storm that lines up every favourable condition, as Bavi is doing now, can then reach for a higher peak than it ever could have over a cooler sea. The warmed baseline does not push every storm to the ceiling. It simply raises the ceiling that the lucky or unlucky storms can reach. There is a related idea that has been drawing more and more concern from scientists, and it is the notion of marine heat waves. Just as the atmosphere can have heat waves, so can the ocean, prolonged periods where a stretch of sea runs much warmer than normal. When a tropical cyclone crosses one of these warm pools, especially one where the warmth runs far below the surface so the storm cannot churn up a cold break, it can intensify with startling speed. Some of the most alarming rapid intensification events in recent memory have happened when a storm crossed exactly such a warm pool. The Philippine Sea that Bavi is crossing right now has that character, warmth that is not just at the surface but banked far below it, and that is a large part of why the forecasters expected explosive strengthening even when the storm's winds were still modest. Now connect this to the trend that worries scientists most, because it is not really about any single storm. What the research increasingly suggests is that rapid intensification itself, the specific behaviour that steals warning time, is becoming more common as the oceans warm. Storms are, on average, more likely now to undergo these sudden leaps in strength than they were in decades past. Think about what that means in human terms. The single most dangerous behaviour a storm can exhibit, the one that turns a manageable forecast into a monster overnight, the one that outruns the ability of communities to prepare, is the behaviour that a warmer ocean makes more likely. Bavi is a vivid, real-time example of exactly this trend, and it is aimed at American citizens. I will say once more, because intellectual honesty demands it, that none of this means a warming ocean created Bavi or aimed it at the Marianas. Storms have always formed here, and always will. What the science supports is narrower and, in its own way, more unsettling. The warmed baseline raises the odds of the extremes, it lifts the ceiling, it makes rapid intensification somewhat more likely, it shrinks the gaps between serious storms for a place like the Marianas, it loads the dice without determining any single role. That is the honest framing, and it is enough all by itself to explain why a neutral year with no strong El Niño can still hand 200,000 Americans a storm reaching for Category 5 in the first week of July. And this brings us back around to the central thread of tonight, the thread that ties the warmed ocean to the keyhole we're watching through. Here is the uncomfortable convergence. The same warming that is raising the ceiling on these storms, making them stronger and quicker to intensify, is happening in an era when our ability to precisely measure them in this part of the world has not kept pace. The storms are getting more capable of surprising us, and we're still watching many of them through the narrow window of satellite estimation, without aircraft flying into their cores. The danger is rising and the measurement is lagging. That gap between how dangerous these storms can now become and how precisely we can see them coming is the real story underneath Bavi. And to appreciate just how far the top of that scale can go, it helps to look at the single, most extreme example the record has ever produced, the storm against which all others are measured. Part 10. The Yardstick. Whenever meteorologists want to describe the absolute upper limit of what a tropical cyclone can become, they reach for one name, and it is a name from the same ocean Bavi is crossing right now. In 1979, a typhoon named Tip formed in the Western Pacific and grew into the most intense tropical cyclone ever reliably measured on Earth. Its central pressure fell to about 870 millibars, a figure so low it still stands as the record decades later. Its sustained winds reached around 190 miles per hour. And perhaps most staggering of all, its wind field, the full breadth of the storm from one edge to the other, spanned roughly 1,380 miles, about 2,220 kilometers, large enough that if you laid it over the United States it would stretch across nearly half the country. Tip is the yardstick. When we ask how bad can it possibly get, Tip is the answer the record gives us. Now, I want to be clear and grounded here, because it would be irresponsible to tell you that Bavi is going to be another Tip. Tip was a singular event, an extreme outlier even among super typhoons, and the overwhelming likelihood is that Bavi, as fearsome as it is, will not touch that all-time record. But here is what makes the comparison worth raising rather than dismissing. Some of the model guidance for Bavi, the outlier runs at the edge of the possibility envelope, have shown the storm reaching central pressures in the range of the low 870s, numbers that flirt with the territory that only Tip and a tiny handful of other storms have ever occupied. Those are not the most likely outcomes. They are the extreme tail of what the models consider possible. But the mere fact that Bavi's possibility envelope includes pressures approaching the all-time record tells you what kind of storm we're dealing with. This is a system whose worst-case scenario is measured against the worst storm ever recorded. Think about why that matters for the keyhole problem we discussed. Tip's record intensity was established in an era, and this is the irony, when reconnaissance aircraft were still flying these Western Pacific storms. The remarkable measurement of 870 millibars was taken by an aircraft that flew into the storm. That program no longer exists for these systems. So if Bavi were, against the odds, to approach that kind of extreme intensity, we would be trying to measure a potentially historic storm through the same narrow satellite keyhole we have already discussed, without the aircraft that captured Tip's record in the first place. We have, in a very real sense, become less able to precisely measure the most extreme storms, even as the ocean has grown more capable of producing them. The yardstick was made with tools we no longer use on these storms. Let me give you a fuller sense of just how extraordinary Tip was, because the scale of it is genuinely hard to hold in the mind. When its central pressure fell to around 870 millibars, it set a mark that has never been beaten in the decades since. Its winds near 190 miles per hour placed it at the absolute ceiling of what tropical cyclones have been observed to achieve. And its size was almost beyond belief, a circulation so enormous that its winds spanned a distance that could stretch across nearly half of the continental United States. A single storm, larger than most countries, with the lowest pressure ever measured, spinning in the same ocean Bavi is crossing right now. That is the record this basin holds, and it is a reminder that when we call the Western Pacific a factory for monsters, the word monster is not an exaggeration. It is a category of storm this ocean has actually produced. Tip is the extreme, but it is not alone. The Western Pacific has generated a whole lineage of storms at the very top of the intensity scale, systems whose names are remembered for the destruction they brought or the records they set. Some reached winds that rivaled Tip's. Some made catastrophic landfalls that reshaped entire coastlines and cost thousands of lives. The point of naming this lineage is not to predict that Bavi will join it at the very top, but to establish the range of what is possible in these waters. When a storm here is forecast toward Category 5, that forecast sits within a history of storms that have gone further still. The ceiling is very high, and this ocean has proven again and again that it is willing to reach for it. Now bring that back to the Marianas specifically, because there is a particular rarity worth understanding. A direct pass of a Category 5 strength storm over these specific islands at this specific time of year would be an unusual event even by the standards of a region accustomed to typhoons. That is precisely why forecasters raise the possibility that Bavi could be a candidate for the strongest July typhoon to make a direct Marianas pass in the reliable record. It is not that typhoons are rare here. They are not. It is that a storm of this particular ferocity, on this particular track, this early in the season, sits at the extreme end of what the historical record contains for these islands. The people of the Marianas know typhoons intimately. What they may be facing this weekend is something closer to the worst end of what their history has to offer, and that is exactly why the uncertainty in the measurement matters so much for a storm reaching into this range. When a system is climbing toward the top of the scale, the difference between one number and another, between a strong Category 4 and a full Category 5, between 150 knots and something higher, is the difference between severe damage and total devastation for the structures and communities below. Those are precisely the distinctions that are hardest to make from satellite imagery alone, precisely the distinctions where the keyhole blurs the picture. So we find ourselves in the unsettling position of watching a storm reach into the rarest and most dangerous part of the scale, over American islands, with the tools least able to tell us exactly where in that dangerous range it will land. I raise tip not to frighten you with a worst case that probably will not happen, but to give you a sense of scale, a sense of the ceiling. When the forecasters put 150 knots and Category 5 on the table for Bavi, that is already an extraordinary, dangerous storm, and it is doing that while sitting comfortably below the all-time record, in a possibility envelope whose upper edge brushes against the most extreme storm ever measured. That is the range we're talking about tonight for the 200,000 Americans in the Marianas. Not a run-of-the-mill typhoon, a storm whose realistic forecast is Category 5 and whose outlier scenarios approach the record books. The question, once again, is exactly where in that range Bavi will land and whether we'll know precisely enough and soon enough to help the people underneath it. And answering that question depends on a small number of specific things the storm is about to do over the next few days. Let me tell you what the forecasters are watching for. Part 11. The next 72 hours. Over the next 72 hours, the fate of the Mariana Islands is going to be decided by a handful of specific processes inside and around this storm, and the forecasters are watching each of them with intense focus. I want to walk you through what they are looking for, because it will help you understand the updates you hear over the coming days, and it will show you just how much can still change between now and the moment Bavi arrives. This is not a settled outcome. It is a storm in motion, and the next 3 days are where the story gets written. The first thing they are watching is the raw intensification itself. Will Bavi keep climbing toward and past the 150 knot projection, or will it level off? As long as the storm stays over that exceptionally warm water with the warmth running far below the surface, as long as the winds aloft stay gentle and the outflow stays clean, the engine has everything it needs to keep strengthening. The forecasters are watching the satellite presentation hour by hour, looking for the signs, a clearing, sharpening eye, colder and colder cloud tops, a tightening symmetry that tell them the storm is still deepening, and they are watching through that same imperfect keyhole we discussed, inferring the strength from the appearance, without an aircraft to confirm it. Every new satellite image is a new reading on whether the monster is still growing. The second thing they are watching is a process with a technical name that has enormous consequences, and it is called an eye wall replacement cycle. In the most intense tropical cyclones, the ring of towering thunderstorms that surrounds the eye wall where the strongest winds live, can sometimes be choked off by a new, larger ring of storms forming outside of it. When that happens, the old inner eye wall collapses and the new outer one contracts to take its place. During this process, something important happens. The storm's peak winds usually drop temporarily, but its wind field spreads outward, meaning the dangerous winds cover a larger area, even if the very strongest gusts ease for a while. For an island chain, an eye wall replacement cycle is a double-edged thing. It might mean the absolute peak intensity is a little lower at landfall, but it might also mean the destructive winds are spread across more of the islands. Whether Bavi undergoes one of these cycles, and exactly when, could significantly shape how the storm affects the different islands. The forecasters are watching for it closely. The third thing, and perhaps the most consequential for who gets hit hardest, is the track. I told you earlier about the disagreement between the models, the American guidance leaning toward Tinian and Saipan, the European guidance leaning a bit farther south toward Rota and Guam. Over the next few days, that disagreement will resolve, one way or another, as the steering currents in the atmosphere become clearer and the models converge. The forecasters are watching the ridge of high pressure that is steering Bavi, because small changes in the strength and position of that ridge translate into large changes in where the storm goes. A ridge that holds strong pushes the storm more directly west toward one set of islands. A ridge that weakens sooner lets the storm begin its turn toward the north earlier, shifting the threat. On islands this small, that difference is everything, and it may not be fully clear until the storm is quite close. And there is a fourth thing they are watching, one that ties directly back to the thread that runs through this entire briefing. They are watching for any opportunity to get a better measurement. As the storm draws closer to the islands, it comes within range of instruments that a mid-ocean storm is beyond. Radar on the islands, surface observations, the whole array of tools that can finally begin to check the satellite estimates against reality. In a sense, the closer Bavi gets, the better we will be able to see it. But the trade-off is brutal, because the better we can see it is also the closer it is to the people it threatens. The clarity arrives at the same time as the danger. That is the cruel arithmetic of watching a storm through a keyhole. We will know how strong Bavi truly is right about the time it is close enough to prove it. Let me linger on that eyewall replacement idea for a moment, because it is one of the most consequential and least understood processes in a major storm, and it could genuinely shape what happens to the different islands. In the strongest tropical cyclones, the inner eyewall, the ring of the fiercest thunderstorms surrounding the calm eye, is where the peak winds are concentrated in a tight band. But a storm that intense can begin to build a second, larger ring of thunderstorms outside the first. That outer ring gradually chokes off the inner one from its supply of warm, moist air. The inner eyewall weakens and collapses, and the outer ring contracts inward to take its place. While this is happening, the storm's very highest winds usually ease somewhat, but the field of dangerous winds spreads outward over a wider area. For a chain of islands, this is a genuine wild card. A storm caught mid-cycle at its closest approach might spare any single island the absolute worst gust, while subjecting more of the chain to destructive winds overall. Understand that forecasters cannot yet reliably predict exactly when one of these cycles will occur, which is one more source of uncertainty layered onto an already uncertain forecast. They watch the satellite imagery for the telltale signs, the appearance of that outer ring, the widening of the eye, and they adjust their thinking as it unfolds. But the timing is difficult, and the difference of a few hours in when the cycle happens could change which island catches the storm at its most concentrated. This is the kind of detail that will only resolve as the storm draws close, and it is one more reason that every island in the chain has to prepare for the worst, rather than gamble on being spared. I want to name too the specific nightmare that rapid intensification poses for the people whose job it is to warn the public. Emergency preparation takes time, opening shelters, moving supplies, communicating with the public, helping the vulnerable, all of it unfolds over a day or more. Warnings are built around that timeline, but when a storm rapidly intensifies close to land, it can outrun the entire warning process. A community that was told to expect a strong storm can find itself facing a catastrophic one with too little time left to fully adjust. This is the exact scenario forecasters lose sleep over, and it is why they leaned forward so hard on Bavi, issuing the watches and widening them even while the storm was still building, precisely so that the 200,000 people in its path would not be caught flat-footed if it makes one of those sudden late leaps in strength. And all of this, every one of these processes is being tracked through the same imperfect keyhole we have discussed all night. The intensification, the eyewall cycles, the subtle shifts in structure are being read from satellite imagery, inferred rather than directly measured, until the storm comes close enough for island-based instruments to finally weigh in. The forecasters are doing extraordinary work with the tools they have, and those tools are genuinely impressive. But there is no substitute for flying into a storm and measuring it, and for these Western Pacific systems, that is not happening. So we watch, and we infer, and we warn, and we wait for the storm to come close enough to tell us the truth, knowing that by then it will be nearly upon the people who most need the answer. So over the next 72 hours, keep your attention on those four things. Is it still intensifying? Does it go through an eyewall replacement cycle? Where does the track finally settle? And how much better can we measure it as it closes in? Every one of those questions bears directly on what happens to the 200,000 Americans in the Marianas, and not one of them is fully answered yet. This is a live storm, and the story is still being written in real time. But before we look at how those people are preparing, I have to address something else, because whenever a storm like this makes the news, a particular set of claims comes with it, claims that this storm is not natural at all. I want to take those claims seriously enough to actually examine them and then show you what the evidence really says. Part 12. The claim that someone made this. Every time a storm like Bavi rises to prominence, a certain set of ideas rises with it, and I think the honest and respectful thing to do is to address them directly rather than pretend they do not exist. The claim, in its various forms, is that a storm this powerful, arriving at this moment, on this track, cannot be natural, that it must have been engineered, or steered, or amplified by some human hand, whether through weather modification programs, or ionospheric heating facilities, or some other secret technology. When people watch a monster explode toward populated islands, it can feel almost intuitive that something so destructive must have been aimed. I understand why the idea has pull, so let us actually examine it, seriously, on the evidence. The first thing to understand is the sheer scale of energy involved, because scale is where these claims collapse. A mature tropical cyclone is not a small thing that could be nudged by a machine. The energy that a storm like Bavi releases, primarily through the condensation of water vapor as it builds those towering clouds, is on the order of 10 to the 14th or even 10 to the 15th watts, running continuously. Let me put that in perspective. That is a rate of energy release comparable to many times the total electricity generation of the entire human race, all our power plants combined and then multiplied over. There is no facility, no array of antennas, no device anywhere on Earth that produces or directs a fraction of that power. Asking whether a human installation steered Bavi is like asking whether someone redirected a river by breathing on it. The energies are not remotely in the same universe. The storm dwarfs anything we could bring to bear by an almost incomprehensible margin. The second thing to understand is that we already know, in detail, why Bavi is moving where it is moving, and it has nothing to do with steering by any secret hand. Tropical cyclones are carried along by the large-scale winds around them, most importantly by the position and strength of the subtropical ridge, that broad area of high pressure I mentioned earlier. This is not mysterious. It is measured every day, mapped by weather balloons and satellites and models, and it is the same mechanism that steers every storm in every ocean. Bavi is going west-northwest, because the ridge to its north is pushing it that way, exactly as the physics predicts, exactly as thousands of storms before it have gone. There is no need to invoke a hidden technology to explain a track that is fully accounted for by the ordinary, well-understood flow of the atmosphere. And the third thing, the one I most want you to sit with, is that the genuine uncertainty in this storm, the satellite keyhole, the lack of aircraft, the estimated rather than measured intensity, is the exact opposite of a cover-up, even though it is the thing most often pointed to as evidence of one. When people hear that we cannot measure Bavi precisely, some conclude that the true numbers are being hidden. But think it through. If there were an effort to conceal this storm's real strength, we would expect confident, precise, unwavering numbers designed to reassure. Instead, what we actually have are forecasters openly telling us about the limits of their tools, publicly flagging the uncertainty, widening the watches to cover more islands precisely because they cannot be certain of the exact track and strength. Transparency about uncertainty is the fingerprint of honest science, not of concealment. The blind spot is real, but it is a limitation of observing systems that everyone can see, and that the professionals themselves are the first to admit. That is not what a cover-up looks like. That is what candor looks like. There is a related version of these claims that deserves its own answer, the idea that a storm this strong is somehow proof of a hidden agenda, whether it is being blamed on secret manipulation or dismissed as a fabricated exaggeration. Both of those framings, opposite as they seem, make the same error. They assume that a storm reaching for Category 5 must be a departure from nature, something that requires a human explanation, either as a cause or as a hoax. But everything I have laid out for you tonight shows the opposite. Bavi is exactly what nature produces when a warm ocean, a favourable atmosphere, and the physics of a heat engine all line up over the Western Pacific in the first week of July. There is no need for a secret cause because the ordinary causes are more than sufficient, and there is no basis for calling it exaggerated because the forecasters are being transparent about both the threat and the uncertainty. The honest reading of Bavi is not that someone made it, or that someone is faking it. The honest reading is that the ocean is fully capable of building a storm this dangerous entirely on its own, and it has done so, and it is aimed at American citizens. I take the time to walk through this carefully because I think the people who raise these questions are very often responding to something real, a genuine sense that a storm this dangerous ought to be within someone's control, that it is unbearable to think such power is simply loose in the world, unowned and unaimed. But the truth, as is so often the case, is both more frightening and more honest than the conspiracy. No one made Bavi. No one is steering it. It is the product of a warm ocean, a favourable atmosphere, and the indifferent physics of a heat engine running at full throttle. It was not aimed at the Marianas by any hand. It is simply going where the winds carry it, and the winds are carrying it toward 200,000 Americans. That is not a comforting thought. But it is the true one, and the true one is what those people need, because you cannot prepare for a storm by blaming it on a machine. You can only prepare by facing what it actually is, and facing what it actually is right now is exactly what those 200,000 people are doing. Part 13. What 200,000 people do with a deadline. Right now, across Guam and Rota and Tinian and Saipan, a familiar and grim choreography is underway, the choreography of an island community preparing to be hit. It is worth describing because it is easy to talk about 200,000 people as a number and forget that it is 200,000 separate lives, each one making decisions tonight that could determine how they come through the next few days. The forecasters have given them a deadline, and that deadline is the 4th of July. Everything that needs to be done to be ready has to be done before the impacts arrive on Sunday. And so, on a weekend that for the rest of the country means barbecues and fireworks, these Americans are boarding up windows and filling water containers and deciding where to shelter. Consider the specific challenges of preparing on an island so far from anywhere else. When a storm threatens the mainland, supplies can be trucked in from neighbouring states, and if the shelves empty in one town, the next town over may still have what you need. On Guam or Saipan, there is no next town over in that sense. What is on the island is what there is. Fuel, generators, plywood, bottled water, non-perishable food, all of it has to have arrived by ship or plane in advance, and when a storm is bearing down, demand spikes far beyond what the local supply can easily meet. Families who have lived through storms before know to prepare early, but even the best prepared community faces hard limits when it is separated from the rest of the country by thousands of miles of ocean. The isolation that makes these islands so vulnerable during the storm also makes them harder to provision before it. Now layer back in the reality we discussed earlier, the reality of Sinlaku. Some of the people preparing tonight are doing so in homes that were damaged months ago and only partly repaired. Some are looking at a roof that was patched after the last storm and wondering whether the patch will hold against winds near 170 miles per hour. Some have already spent their savings and their energy on one recovery this year and are now being asked to brace for another blow before the first one has healed. The psychological weight of that is real, and it deserves to be acknowledged. Preparing for a Category 5 storm is exhausting under any circumstances. Preparing for one while still recovering from the last one is a kind of endurance that most of us, safe on the mainland, will never be asked to summon, and there is the particular cruelty of the timing to sit with. The preparation deadline is the 4th of July, the day this country celebrates itself. For 200,000 of our fellow citizens, this 4th will not be a holiday. It will be the last day to get ready. The fireworks, if there are any, will compete with the anxious checking of forecast updates, the last runs to whatever supplies remain, the difficult conversations within families about whether their home is strong enough or whether they need to move to a public shelter. It is a strange and sobering thing to realize that, while much of the nation marks its independence, a piece of that same nation, just as American as any other, is battening down against one of the strongest storms on the planet, and doing so largely out of the national view. I want to say something plainly here, because it matters. These islands and the people on them are not a footnote. They are not a distant curiosity. They are American communities facing an American disaster, and the fact that they sit on the far side of an ocean does not make their peril any less real or any less deserving of the country's attention. When this storm passes, and the images of the damage begin to come in, I hope the mainland looks. I hope the resources flow, because the recovery from a storm like this, on islands this isolated, will be long and hard, and it will need the full weight of the nation behind it, especially for communities that were already rebuilding from the last one. The 200,000 people in Bavi's path are not asking to be spared attention. They are simply, right now, doing the quiet, exhausting work of getting ready, on a deadline that falls on the nation's birthday. If you're watching from somewhere safe tonight, I would ask you to hold them in your mind, not with panic, but with the kind of steady attention that these situations deserve. And if you're watching from within the reach of this storm, from the islands themselves, then you already know what you need to do, and the professionals on the ground are the voices to follow, not me. Finish your preparations. Take the watches seriously. Understand that the uncertainty in the exact strength and track is not a reason to relax, but a reason to prepare for the worst plausible version of this storm, because on islands this small, the worst plausible version is very much on the table. That is what facing the storm honestly requires. And facing it honestly is the only thing that has ever helped anyone come through one of these. There is a particular decision that many families across these islands are wrestling with tonight, and it is the hardest one of all. Do we stay in our home, or do we go to a shelter? For a family whose house is solidly built and sits on high ground, staying may be the right and safe choice. For a family in an older or weaker structure, or in a low-lying area exposed to surge, leaving for a hardened public shelter may be the only choice that protects their lives. This is not an easy decision, and it is loaded with everything that makes leaving hard: the reluctance to abandon a home to the storm, the difficulty of moving elderly relatives or young children or pets, the uncertainty of not knowing exactly how bad it will get. And that uncertainty ties directly back to the keyhole. When you cannot be fully certain how strong the storm will be, or exactly where it will strike hardest, it is that much harder to make the call. The honest guidance in the face of that uncertainty is to prepare for the worst version, because on a small island, the cost of underestimating a Category 5 storm is far higher than the cost of over-preparing for one. Consider also the quiet heroism that these situations always summon, the part that never makes the forecast. In every island community facing a storm like this, there are people checking on their neighbours, making sure the elderly widow down the street has a ride to the shelter, that the family without a car has a way to get supplies, that no one is left alone to face it. The strength of a community in a disaster is not measured only in the strength of its buildings. It is measured in these bonds, in the willingness of people to look out for one another when the ordinary systems are stretched to their limits. The people of the Marianas have faced storms for generations, and they carry that hard-won knowledge of how to hold together when the ocean turns violent. That is a real source of resilience, and it deserves to be named alongside all the frightening numbers. I also want to be honest about what comes after, because the storm itself is only the beginning of the ordeal. When a Category 5 strength storm passes over a small isolated island, the recovery is not measured in days. It is measured in weeks and months, sometimes longer. Power can be out for extended periods. Water systems can fail. Supplies have to be brought in from thousands of miles away. Roofs and homes have to be rebuilt, often for the second time in a single year, for the communities still recovering from the earlier storm. This is the long tail of a disaster like Bavi, the part that unfolds after the cameras, if there ever were any, have moved on. And it is precisely the part where the attention of the mainland matters most, because a distant, isolated community rebuilding from catastrophe needs the sustained support of the nation it belongs to. So when I ask you to keep these 200,000 people in your thoughts, I am not asking only for this weekend. I am asking for the weeks that follow, for the long recovery that a storm of this magnitude will demand. These are American communities, and they will need American help, and they will need it long after the winds have died down. That is the fuller shape of what Bavi means. Not just a terrifying weekend, but a hard road afterward, walked by people who were already tired before it began. Which brings us finally back to the question that has haunted this entire briefing. The question that sits underneath every number and every forecast and every watch. How strong will Bavi actually be when it reaches them? And will we know in time for that knowledge to matter? Let me close by facing that question directly. Part 14. The number we do not yet know. For 3 nights and days now, the ocean east of Guam has been building something, and we have been watching it grow through a narrow window, unable to reach out and touch it, unable to fly into it, able only to estimate from a distance what it is becoming. That is where we are tonight. Typhoon Bavi is somewhere in the Philippine Sea, feeding on warm water that runs far below the surface, its winds forecast near 150 knots, its gusts toward 180, its seas building toward 45 feet, its track splitting between the central islands and the southern ones, its arrival timed for Sunday into Monday, its preparation deadline falling on the 4th of July. And the single most important number in all of that, the storm's true strength, remains an estimate. A careful, expert, best available estimate, but an estimate. I have tried tonight to hold two truths in front of you at once, because both are real and neither cancels the other. The first truth is that this is a genuine emergency for 200,000 American citizens who have nowhere to run, on islands still rebuilding from an earlier blow, facing a storm with Category 5 potential on a holiday weekend. That truth demands seriousness, demands attention, demands that we not look away simply because these Americans live far from the mainland spotlight. The second truth is that our ability to precisely measure the thing bearing down on them has not kept pace with the ocean's growing ability to produce monsters. We are watching one of the most dangerous storms on Earth approach American soil through the keyhole of satellite estimation, without the aircraft that once flew into storms like this and read their true strength directly. The danger is rising, the measurement is lagging, and the gap between the two is where the fear lives. Here is what I keep coming back to, the thing I cannot quite shake. When Typhoon Tip set the all-time record in this same ocean decades ago, we knew it was the record because an aircraft flew into it and measured it. If Bavi, against the odds, were to approach that kind of extreme, we would be squinting at it from space, estimating, inferring, hoping the pattern matching holds at the very edge of the scale where it is least tested. We built our understanding of the worst storms with tools we have since set aside for these waters, and now the waters are warmer and more capable than they were when we built it. There is something profoundly uneasy in that. We have made the ocean more dangerous while making ourselves, in this corner of the world, a little more blind to exactly how dangerous. And so the core mystery of Bavi is not whether it will hurt the Marianas. It will bring damaging wind and flooding rain and battering seas to American islands, and the only question is the degree. The real mystery is the one hanging over the number itself. How strong is it truly right now, out there in the dark over the warm water? Is the satellite reading it correctly, or is it stronger than the estimate suggests, or weaker? We will find out, but we will find out the hard way, in the way we always do with these storms, as it closes the distance and finally comes within reach of instruments that can check the guess against the reality. The clarity is coming, but it is coming at the same speed as the storm, and it will arrive at the same moment. We will know exactly how strong Bavi is at almost precisely the moment it proves it, over the heads of 200,000 people who are, tonight, doing everything they can to be ready for a number none of us can yet be certain of. And notice how neatly the two great unknowns of this storm fold into that single question. We do not fully know how strong Bavi is, because we are reading it from space without an aircraft to check the estimate. And we do not fully know exactly where its worst winds will fall, because the steering ridge has not yet made up its mind. Both of those unknowns resolve only as the storm closes the distance, which means the moment of greatest clarity and the moment of greatest danger are the same moment. That is the trap these Western Pacific storms set, and it is the trap Bavi has set for 200,000 Americans this weekend. That is the strange and sobering place this leaves us. Somewhere east of Guam, a storm is deciding how large it will become, and it is not consulting us. It is answering only to the warmth of the water and the calm of the winds aloft and the indifferent arithmetic of a heat engine at sea. We are not steering it. We are not even fully measuring it. We are watching and estimating and warning and waiting. And on a chain of small American islands on the far side of the date line, 200,000 of our fellow citizens are watching the same horizon we are, waiting for a storm whose true face will not be revealed until it is already upon them. Keep them in your thoughts this weekend, and keep watching that horizon with me, because the next 72 hours will tell us at last exactly what the ocean has built.